I've done it a little bit differently this time. I've named my presentation "Pushing the Limits in Biomarker Analysis." But first of all, I will give a few facts about myself and also let you in on my story. So as Colin said, my name is Thomas. I am one of the co-founders and CEO and Chief Scientific Officer of the contract lab, Vitas Analytical Service, based in Oslo, Norway. Ever since I was a young boy, I've been really fascinated by the natural sciences and especially chemistry. And when I got older, I actually started my studies at the University of Oslo, studying chemistry. And when I reached the master level, the Master of Science level, after some years, I had a task from a professor at the medical faculty. His name was Rune Blomhoff. And the task was to develop some methods, analytical methods for vitamin A compounds, more particularly retinoids in blood samples. So I went on and I developed a fully automated, multi-dimensional, high-throughput method for very low concentrations of retinoids in blood samples. And the results was quite good, so I was encouraged to also continue with a PhD. So I started on the PhD at the medical faculty at the same university in Oslo. And this is the front page of my thesis. It was published in 2007. It's 15 years ago now. And one of the applications, so what I really did was I applied the methods that I developed during my master's in some applications. And many of these applications was related to developmental biology. That's embryonic development, you know, how the child or the embryo is developing during the pregnancy. And for this, we used some models. We used mice and chicken. And what you see on this picture, the yellow creature is a mouse embryo. So the mice pregnancy is about 21 days long. And this embryo is 12.5 days after fertilization. So it's not born yet, it's an embryo taken out from the mother. So what we did here, and these embryos, they are quite small. You know, if you compare with the head of a matchstick, you can see it's about 1.5 millimeter long. And in this work, we actually dissected out small segments of the central nervous system on these embryos. So we collected quite a few, and we pulled them, and we applied my method for the analysis of these retinoids in these really tiny samples. And since this is really tiny samples and really low concentrations of hormones, retinoid hormones, it was a very challenging task. So these retinoids, they look like this, the structure, the chemical structure you see.
Sind diese Retinoidsäuren das Molekül, nach dem wir gesucht haben?
In the body, in any living animal. So it's kind of the conductor of the cell division and decides what the stem cell should develop into. Should it be a muscle cell, a brain cell, or a fat cell? It also has a lot of influence on the speed of the cell division. So to mention a couple of things that's quite fascinating and that retinoic acid has a lot of influence on, consider these two examples. So you might know that the reindeer, the deer, and the moose has antlers that they lose during the winter. And before summer, it has totally grown out again. It's a massive cell division, and it's quite fascinating that it turns out in exactly the same shape every year, except it has an extra tag on it. Another example is the salamander. You know, the salamander can lose its tail if it's caught by an animal or a human to get away. But within a year, a perfect copy of this organ, the tail, grows out again. And in both these processes, retinoic acid is very important. And imagine if we can understand this and have an arm grow out again if it lost during war, for instance. So I think this was very intriguing research, and I was highly motivated to work with this during those days. And this retinoic acid is a metabolite of vitamin A. And vitamin A is a really essential nutrient, meaning it needs to be fed to the body. The body cannot produce it itself. So you need to eat this to have sufficient levels of vitamin A and retinoic acid, which is a metabolite. So if you have too little of vitamin A, you will have some issues. You will have, the first thing that will happen is that your night vision becomes less good. It causes night blindness. And if you have too much vitamin A, you can have toxic effects. And this is because vitamin A is fat soluble. It will dissolve in the fat storages of your body. And one example is the use of a drug called Roacutan, which is a retinoid, and it's used for treating severe acne. And if a pregnant woman uses this or similar drugs, you will have severe birth defects on the child. For instance, looking like this. So this is one example that's very important to ensure that the body has the correct level of nutrients and building blocks at all times. And this is really what I'm an expert on, biomarker analysis. And this is what my company provides, biomarker analysis service from all kinds of samples, from all kinds of species. And this company has been around for quite a few years now. It's very mature. It was established in 1994. And as you understand, it's kind of a spin-off from my academic career at the University of Oslo. For 16 years, I was a student there, a PhD student. I had a postdoc position. I was a group leader as a senior scientist at the University of Oslo at the medical faculty. And I published quite a few papers. Currently, I have about 60 publications altogether. So we're kind of different. We are an academic lab taking the knowledge developed slowly over many years at the university sector and going commercial. So we are serving the academic institutions that have some ideas turning into small biotech companies, and then they might turn into a pharmaceutical company and even a big pharma company. We also have customers within food and nutrient producers, hospitals, primary healthcare, and a number of startups throughout the world. So we have a GMP certification, meaning that we can work with human clinical studies and also release drug products to the market. So we are inspected by EMA in Europe, FDA in the US. So we are located in this building. This is Oslo Innovation Park. And in this building, more than 300 companies employing more than 3,000 people have their daily work trying to develop an idea from the university into a flourishing business or to some service or some product which is good for mankind. So we are located at the top floor in the newest part of this building, and currently we occupy almost the entire floor. It's about 1,000 square meters. So I usually say that we are 60 workers in this company now, where 24 currently are humans and the rest are robotics or machines. And these robots, they don't really look like this. They are more boring looking like this. But these are really complicated machines, expensive machines that we use to analyze and process the samples that you guys send us every day. So we have a lot of different customers. We have about 1,000 projects each year. And these are the logos of some of the companies and academic institutions that we've been working with the last 6 months. I guess you recognize some of these here. And what we do for these companies are biomarker analysis related, for instance, obesity research or newborn and premature children, which I think is really important to supply. And we also lately, the last year, have been working a lot with fish health. You know, fish farming is big in Norway and is also important as a food source in the world. And fish health, lice issues is a very relevant and hot topic here. And we try to contribute with the analysis on the fish and also in the water related to pollution from this business. Another important field is cancer research. There is a number of cancer companies in Norway, and lately the mRNA vaccine type developed for COVID-19 also has become relevant for cancer vaccine, and we are proud to actually work on this as well. And then we have another customer called Cincino, and I guess you guys know about this company. So this is currently our largest customer. For this company, we do fatty acid analysis from dry blood spots. And you might know from visiting your doctor that the classical way of taking a blood sample is to stick a big needle into your arm and draw multiple tubes of blood looking like this into these tubes. And when you spin these vials down, they turn into a double layer with a red bottom. These are the red blood cells. Then you have the upper yellow layer, and this is the blood plasma. And this blood plasma is what your doctor usually would use for biomarker analysis to see if you're sick, to measure your cholesterol or your glucose or things like that. But Cincino uses a very different approach. So this is the balance test kit. And with this kit, there is no big needles, just a tiny drop of blood collected from the fingertip. And as you can see from this picture, this is a really tiny sample. And often I'm asked, how is it even possible to do the analysis from such a small sample? But since you now know about my history and my work with these guys, the embryos being 1 millimeter long and the dissection of really small parts of the central nervous system from this, you understand that my background with this work actually is the reason that we are able to do the analysis from one drop of blood.
Thomas?
Yeah.
Sorry to interrupt. Could you relocate your headphones? It's just creating a lot of...
Yeah.
Yeah, rubbing against your chair when you're speaking, just creating a bit of background noise. Thank you.
Okay, I see. Right, so I'll continue. So when you dry this drop of blood on the paper, it will be what we call dry blood spots. And so these dry blood spots, they are the whole blood. It's not the RBC fraction, the bottom red layer, or the yellow upper layer. It's everything. So now I will try to explain why the yellow upper part is not very well suited for this type of analysis, fatty acid analysis. So the red blood cells, the bottom part, they are born in the bone marrow and in the core of your bones, and every second 2 million cells are born and die. And when they are born, they live for about 120 days. And so what happens then when you swallow one dose of the balance oil, for instance? Well, you swallow 15 grams of fat, and after some time, the concentration of the fatty acids will start to increase in your blood. For instance, the EPA and the DHA concentrations, they will peak after about 6 hours. Then they will go down again. And when you then take the second dose, the same thing will happen. Another peak after 6 hours in the morning, for instance. And then the third day, the fourth day, and so on. And then this blood will be transported into your heart, and your heart will pump the blood out containing the important nutrients, including the omega-3 and omega-6, to the different organs of your body, including your brain. And omega-3 is really important for the brain because about 60% of the fat in your brain is DHA, one of the important omega-3 fatty acids. And what we really would like to do is to take a sample from the brain to ensure that we have the proper levels of omega-3 in the brain or other organs, but we cannot really do that. And then it's pretty convenient that we have another type of cell floating around in your blood that we can easily access by taking a blood sample. And this cell is fed with omega-3 fatty acids in the same way as the brain. And I told you that these cells are born in the bone marrow. And when you have done this blood containing the omega-3 from your daily dose going in through your heart and then pumped to your to your brain and to your bones. You have newly born red blood cells with high omega-3, and at the same time 2 million with low omega-3 is dying. And then after some time you will have exchanged a lot of the red blood cells containing low omega-3 with high omega-3, and this way the concentration, the blue line here in your red blood cells, will start to increase. And since it takes 120 days to exchange all the red blood cells, this is the time where the concentration will start to flatten out. While in the upper yellow plasma the doctor is using, you will not have this increase because it do not contain cells. So in this fraction, the blood, the yellow plasma, the concentration will only peak after 6 hours and go down again from your daily dose. But as the red blood cells are both things, it's both plasma and the red blood cells, you will have both superimposed on each other. So you can see the blue line is the increasing concentration in the red blood cells, and then the blood plasma peaking. So when the concentration in the red blood cells are low, the spiking from your daily dose will be quite evident, but as the concentration in the red blood cells increases, the spiking will not be visible at all. So this is, I think this is really important to understand why you should not use the yellow plasma, but RBCs or the whole blood containing the red blood cells when you do a fatty acid analysis. But the funny thing is that, if you give the same dose every day to 2 different people, person A, person B, because we are different, we have different genetics, we have different body weight, different fat amounts, and so on, they will not have the same concentration of omega-3s and in the red blood cells and in the brain. So they will behave differently. And this is because of many things, as I said, the genetic background, but I think it's really easy to understand that fat-soluble components like the omega-3, vitamin D, vitamin A, vitamin E, and so on, it will dissolve in the fat you have in your body. And if you have an obese person, which usually have a lot of fat, this person will need to take a lot more of vitamin D or omega-3 supplements to have the same concentration of omega-3 in the blood, because it's the concentration in the blood that's important, because this is what is delivered to these different organs of your body. And when these nutrients arrive in the cells, they are in the case of omega-3 fatty acids, they are included in the membrane of the red blood cells when they are born. So what you see on this picture is red blood cells, and you can see it's hollow. It doesn't have a core, but it has a membrane, and this membrane is built by phospholipids, and these yellow sticks on this phospholipid is the fatty acids. And what happens when you take omega-3 supplements is that some of these are exchanged with omega-3 fatty acids. And this is really important for the function of this membrane. And if you take a closer look at this membrane, this is a quite complicated slide, but you can see these sticks here. These are the fatty acids. This is the polar head on the phospholipid. And this is then the total membrane. This is a bilayer. It's 2 sets of phospholipids. So we have fatty acids here and fatty acids here. And in this membrane, you also have different kinds of other nutrients and components. You can see cholesterol. Cholesterol is included in the membrane to stabilize the membrane. It's really important for the stability of the membrane. And then you can see this long structure here. This is a carotenoid. So these are the color compounds of fruit and vegetables. For instance, in carrots, you have beta carotene. So this is really important antioxidants. And then on the top here, you can see it's vitamin C. So this is a water-soluble antioxidant, while the carotenoids are lipid-soluble. And because they are lipid-soluble, they will go into the membrane, because the membrane is built from lipids. While on the outside, we have the blood, and this is where the vitamin C is soluble. So the function of this antioxidant is to transport the free radicals from inside the cells throughout the membrane. And when it reaches the outside, the blood, it's collected by the water-soluble vitamin C to be transported away. So all these components and nutrients are important to build the cell wall, to keep it healthy, and to clean it as it ages. So all of these are biomarkers, and it's important to ensure that you have the correct levels of these and many, many more nutrients and building blocks in your body. So if I try to summarize a little bit before Colin asked me some questions, it will be that our body is highly dependent on sufficient and correct supply of nutrients and building blocks. And it needs to be the correct level, not too little, not too much. And the other thing is that we are all different. We are different individuals. It's funny when you walk down the street, think about it. We all have one nose, two eyes, one mouth, two ears, but we all look different, right? There is no one except twins that look the same. And the same is true for the inside of your body, right? People think we are the same on the inside, but it's not true. We are as different on the inside as on the outside. And then because of this, we will respond differently to the food we eat and to the same dose of a supplement, for instance, omega-3 or a vitamin D supplement or a drug. So because of this, it can be very useful to do a personal measurement of how a certain dose of a supplement actually is taken up in your body and how it affects your blood concentration. And based on this, what we call personal nutrition, personal measurements, doing the dried blood spot measurements, having your profile, your personal profile, you can optimize what you eat and what dose of supplements or drug you take to achieve a better health. So that's it, Colin. And I have a few more slides to support questions you might have, if you like that.
Brilliant. Thank you very much, Thomas. Fascinating, as always. A real kind of depth delve into that. Thank you very much. You've covered a lot. There's a few questions coming through, which I'll ask in a moment. I'll literally read them as they arrive. But if you don't mind, prior to that, we could just delve into a few other areas that I know are hot topics that people often discuss.
Sure.
With regards to the validity and the reliability of the test. So somebody's at home, they do their pinprick, they put their blood spots on the paper, they send this in the post, it arrives with you.
Yeah.
Can you just talk people through and I guess explain that process, that literal process with regards to what you do with it, how that's protected and how you know that it's a valid measurement?
Well, in any kind of analytical process which is validated, of course, you have done like a validation upfront of the methodology, right? So we examine the accuracy, the precision of the methods. We do stability testing and things like that. But as we do the samples, I think the key thing is that we produce something called quality samples. And these are dry blood spots. What we do is we collect 20 liters of blood from the hospital. We mix this in a big bottle, so it's blended. And then we prepare like thousands of dry blood spots, right? We dry them, we put them in the freezer.
Frozen.
Yeah, they are frozen in the freezer. So every day when we do the Cincino samples or other samples, we take out a few of these samples before, in the middle, and after, and we analyze them. And since these samples are supposed to be identical, they should produce very similar results. So what we do is we use this as a tool to secure that the data produced in this batch is according to what we have seen before. And if it is, then we can release it and the quality is okay.
So off the back of that then, given that you've explained the process of it and the validity and I guess the sensitivity and the reliability of the method, you know, a lot of people and a lot of the questions that are coming through are looking at specific individual tests and they want to say, well, someone's DHA was this to begin with, and then they've been on the product for 3 months and then it becomes that, which really we can't really delve into individual cases in a forum like this because there's so much more information that is needed when you start to look at the individual profile of how a person responds to balance oil and what the test means. But on that notion, though, when somebody gets what you might call a spurious test result, so they'll go in, it might be this, if this happens more with the second test, and they don't see the change they expect to see. First of all, how common is that? And secondly, can you kind of postulate or consider why those kind of individual rates alter to such an extent? Can that be down to the test parameters, or is it more likely individual responses?
It's kind of hard for me to comment on, specific cases because I don't have the information to provide a good answer, I'd say. But I think it's a good example that this is actually why you need to measure, because if it was always as expected, there will be no need to do a personal measurement, right?
Yeah.
So what could happen? There could be some disease affecting the absorption of the nutrient. You could take some medication, right?
Mm-hmm.
But we also know that people think they are better than they actually are, because this is a well-known scientific fact, actually, that people lie, So this is also a reason we're doing objective measurements, because you could ask people, did you take your supplements every day? Oh, yes, I took my supplements every day. No doubt about it, right? But we know it's not true. Of course, some people take the supplements every day, but most people, myself, for instance, I don't take them every day. I forget about a couple of days. And because of that, I actually take 4 every time I take, because I knew that I didn't take the last 3 days, right? So I think there is a multitude of reasons and explanations, but in the end, it's what's in your blood that's important, right?
Mm-hmm.
Because this is what is fed to your organs, to your brain, to your cells.
Mm-hmm.
Of course, there could be like issues like degradation during the traveling from South Africa to Oslo, for instance. I mean, we could be laying around in a mailbox with like 100 degrees in the sun. This could affect it. I mean, the bag, the alumina bag, which is there to protect the sample, could be open, right? For instance, it could contain too much air, or the drying medium inside the bag could have been exposed to moisture, for instance. I mean, there are also a lot of technical reasons that it could affect the analysis, but the only thing we can do is to have these samples, the QC samples, the quality samples, and we know these are good, We put them in every day and we look at how they perform. And if they perform good, we know that this batch of analysis was good. And therefore, we need to say that the samples in between those QC samples are also okay. This is the best thing we can do. And then in addition, there are what we call pre-analytical variation, things happening before the samples arrive in Oslo. We cannot master this, We need to trust that the samples coming in are of the right quality, that they did travel for the right time at the right conditions and so on, and that they will be valid.
Mm-hmm. Yeah, and that's always the difficulty when you're taking a lab-based procedure and it's relying on the quality, the integrity of the sample when it's not captured within the lab, isn't it? That's that huge amount of lack of control over the data sampling.
Right. But one final comment. We do something like 25,000 samples per month now. And I think if we have 5 complaints per month, I think that's top.
Oh yeah, absolutely.
There will always be a few issues, but all over, I think this performs quite well, or extraordinarily well, I would say.
I think the procedure is phenomenal. I think where people think there's an issue is that, and you tapped it a moment ago, it's where they don't get the result they expect. And you're right, people often have a high expectancy and they don't consider individual adaptation and response rate. Whereas the vast majority of people can achieve a index and a ratio within 120 days approximate. That's not the case for everybody, because there is such an individual response. And more often than not, the kind of feedback we get is not around the test itself, I'd say that is impeccable as a procedure. But it's more when someone says this isn't the result I expect, and that's really comes in. And I guess from yourself, which is important, is that assurance over the rigor of the method. So we know the method stacks up, and what we've got to look at is that individual response. And some people require more time, and there are differences, and diet plays a part. There's a huge amount of things that bring those variations. But I have to say, anyone who's listening, these are rare. These are the smallest amount of cases. The vast majority, overwhelming majority, go through on an almost predictable rate. An interesting. Sorry,
I would like to share my screen once now to explain something. Can I do that?
Yeah, absolutely. Yeah.
So looking at, these are, you see that now, the report?
Mm-hmm.
Yeah. So I think one important thing is that people have kind of the wrong way at looking at changes, So let's say one person had a result at just about the yellow line here, the border between yellow and green, right?
Mm-hmm.
And then the next sample is on the other side of this border. So then the result changes from green to yellow, right?
Yeah.
But the actual change is very small, So I think this we see from time to time, that people think that, 1.25, and then it goes down to 1.21, right?
Mm-hmm.
And this is a change, and people, and also because it goes from green to yellow, this is not correct, because you're supposed to get into a higher greener area, right?
Yeah.
So, I mean, I think people don't really understand the kind of science or the, what kind of accuracy or precision you should operate on, because in real life, this doesn't have any important significance at all, right? Because you're just as healthy. Yeah,
absolutely. Yeah, absolutely. And this comes down to, this is a good illustration, actually. What we try to do is capture that response and give it an indication, but it's literally an indication. And when there are these kind of thresholds that we see, and we see this tiny amount of change, people do get really kind of focused on that and get a little bit obsessed. But in reality, it's more about seeing where we're at. The bigger changes are more important than these tiny swans that can just shift across a slight threshold. And it's really looking at where you are overall and the consistency of that response and the overall direction of change,
right,
or maintenance. But you're right.
What's really important is that you are somewhere in this red area, right? Before you start taking the supplements. Yeah, you may be really red, or middle red, or not that red, right? But the thing is that you should start to change this. So you move first into the yellow area and then into the green area. So this big move from red to green is what you should focus on. And if you're still in the green or the high yellow, right, you still have improved your health vastly, going from really bad to much better. And this is what is important, right?
Absolutely. Yeah, that picture paints exactly what I was trying to explain. Definitely. Just to pick up on a question that's come through that I think is an interesting question to ask. Someone's posed and really, I guess I'm looking for your professional opinion. What do you consider to be more of a valuable insight to cardiovascular health? Is it the omega index or ratio, that status, or is it looking at cholesterol markers? What would your comment be?
I would say they are both important. There is not such thing as one thing. I mean, this is never the case. It's complicated, right? So you should optimize all the factors that influence your health, your cardiovascular health. So you should try to have as low cholesterol as possible. You should try to have at least 6 in omega-3 index, preferably 8 or even higher. This will lower your risk for cardiac arrest. And then you have the triglycerides and so on. So I think they are all important, and you should start to work with them one by one.
Mm-hmm. Spoken like a real scientist. The more dimensions of insight, the better. And it's not about excluding. The focus, the aim, the mission is always to gather as much information that's relevant as possible to get the clearest insight.
Yeah.
It's very rare that within research or science that we'll exclude a potential marker that might have a value and tell us something that we might miss just by looking at one thing.
So as you probably know, when you have these risk scores calculating your risk for cardiac disease, it's a very complex algorithm. It contains a lot of things and they have different weight, right? But they are all relevant because they are in the equation. So a risk is calculated from many things, not from one thing.
Yeah, absolutely. Just a few more that have come in around the test that I think it'd be brilliant if you could give a response to. Someone's asked here, would you recommend that someone take the balance test and therefore the product if the person is dealing with lipid metabolic disorder?
I'm not a medical doctor. I'm not sure if I can actually answer that question. So I think I'll pass on that question.
Yeah. And my response, we get a lot of these kind of questions, and I was interested to hear your take on it, Thomas, because my response is always, first of all, if somebody is under the supervision of a medical doctor because of a condition, the best person you can ask with regards to what the procedure should be is that medical supervisor. It's vital. It's not either or. It's a combined approach. So in those kind of instances, speak to your doctor, your practitioner, your GP, ask them for their insight, and then work forward based on that recommendation. That's the key part.
Agreed.
There's one that came through that I'd be keen to pick up if I can just find it here. Because again, the reason I like to do this, and anybody who's come on who kind of is quite involved in working behind the scenes, I like to ask those kind of questions that we get asked quite commonly, just so that people can get a different take on it, really. So if you don't mind, if you can have a bit of patience with me whilst I field some of those in your direction, Thomas.
Sure.
Let me just find this one here that came through earlier on. It's about a negative test going positive. Let's have a look. Hold on. Here we go. So how is it possible that if someone comes from a negative percentage with, for example, linoleic acid, then still scores a positive percentage of GGLA? If you have a negative starting point, you cannot score positively in a subsequent conversion. Can you? That's the question. Sounds like a rhetoric question, but it's actually a genuine question. What do you think, Thomas?
I think it's kind of hard to answer that on the fly. First of all, I would need to see this and have a look. But then again, my company or me, I'm not responsible for the equations or the algorithms calculating the results on the reports. So this is actually, and this is a kind of a misunderstanding. People think that the reports are developed by Vitas, but actually this is Cincino IP and property. So all the reports are on Cincino servers and all the calculations are done by Cincino algorithms developed by some scientific people in Cincino quite a long time back. So I'm not the right guy to ask these questions, actually.
I think you have, though. And I appreciate your comment on that. But I think you answered it with the very first opening comment, which is, again, what you have to understand is that there's a lot of feedback and there's a lot of interaction that goes on with regards to the parameters that are measured. And it is so difficult to comment on an individual case unless we're looking at the full array of data. And better still, it's far better if we can have a conversation with the person, because more often than not, there are other things around this that will influence what it is that we're seeing. Yeah. So we encourage everybody, anybody who's taken part today, we do encourage you. Those are the sessions that we do with regards to other partners, when we do sessions that are more intimate than this, really, and where people like myself and Ida and Emily and all these people take part, and Paul, that's a better opportunity. And the events that we run, they're a better opportunity for those kind of things to be discussed. But certainly having those conversations with your Zinzino partner and having a look at that data together is a really valuable way to gain an insight to what it is that you're looking at and what that data means. We work pretty much all the time. We are looking towards refinement and looking at how we can better communicate those results and those findings back to you so you can have a clearer, more straightforward understanding. The problem we have is that people are becoming really, really savvy and want to know more and more and more. So we then go from the point of, well, how far do we delve into the science and the data and the research and those kinds of metrics? How far can we go that way without losing most of the people? So it's a balancing act. And
but I think it's really important that people ask these questions, and I think hopefully there is. I mean, I know there is a support system in Zinzino. I think this is actually not my decision to make, but I think people should be heard. There should be a forum for asking these questions, and I think the scientific group, including you, should compile these questions and maybe create a FAQ, a frequently asked questions site, where the most frequent asked questions are answered. And maybe I could suggest that a topic of a future session like this should focus on the reports and how you should read reports and what they actually mean, you know? And then I think you and your group will be more prepared in answering this type of questions. So I think there is need for more focus on the reports, what they mean, and how you should read them actually.
Yeah, and that's really useful. And there's two parts to that. Is that first of all, Zinzino's ambition is to have the world's best customer support office, and that's why wherever possible we do encourage people to get in touch with customer support and ask those types of questions, because that informs us as to what it is that people want to know, and then behind the scenes we can work on developing those responses and having this area furnished. And the good news is, it's always good to be prepared, is that we're already working on, I mean, it's in flight anyway. This process is constantly in flight, but that's already high on our agenda, which is to make more of that information available. And in my time since I've been at Zinzino, I've delivered several of those sessions where we literally go through the feedback and explain what it is and how that data has been interpreted and what it means in real terms. And I know that a number of my colleagues at Zinzino have done those sessions as well. And that's very high on our agenda to do more and more of that, because it's upon us to, and this is really what this has been about with yourself today, Thomas. It's upon us to demystify the science. It's upon us to make it accessible, but also in doing so, not for it to lose its credibility. Because if you water it down too far, it loses its substance. And so it's playing that balancing act.
But this is classical, the balance, because science is complicated. As you say at the start, you need like 20 years of education to understand this, you know. But we are attempting to explain something very difficult to ordinary people, to non-scientists, you know. And as you say, you lose something on the way, and you could lose too much. But I think we need to try. We need to try, because it's so important to communicate this to as many people as possible. And then there will be misunderstandings, but we never can stop to try, right? So we need to try to simplify in the correct way and visualize this in reports like the Zinzino reports, and then try just to improve them over time.
Absolutely. And on that note, before we finish up, because I've got you for a couple more minutes, with regards to the notion of improvement and forwards, what's on your horizon, Thomas? What do you see? I mean, what's your insight on where all this notion of being able to test certain parameters that relate to our lifestyle behaviors, our nutrition, the amount of activity, where do you see it going? And where, I guess, are the next steps for you at Vitas with regards to the refinement of your methods and what it is that you're trying to achieve?
Well, I think it's pretty clear that people will not accept anymore to be like handled as a big group of people. You know, people would like personalized treatment, you know, would like any. So this is what we call personal medicine, personal nutrition, and so on. So this is coming right now. So instead of like having a box where it says take 10 micrograms of vitamin D, you should know how much you should take as an individual to give you optimal health. And I think you will see more and more of this, you know. So I think the classical way of taking a blood sample, going to the doctor, is going to disappear. You're going to order something online. You're going to have this kit, like we've seen with the COVID kits, you know. People order them home. They know what's happening to their body, if they have the disease, if they are been infected, if they have produced antibodies, and so on. And this is the same as with the omega-3, and I think we will see the same for the other nutrients like cholesterol, the vitamin D, the vitamin A, the vitamin C, and so on. And after a few years, we will have this big panel of biomarker analysis that you can order just doing a drop of blood from your finger. And I think it will not stop before we have a full coverage of what is important to
kind of been at the forefront of making that accessible so that people can lift under the hood and have a look at what's going on for them and where they're at and the choices that they need to make and how it empowers that.
But I think also, Colin, that there is one really important distinction, you know, because when you go to your doctor and do some blood measurements, this is to see if you are sick now, you know. Mm-hmm. If you have like heart attack or high cholesterol, or you have cancer or HIV or something, if you're sick, right? Mm-hmm. So the only measurements that the doctor will offer you is to see if you're sick. But what we are offering is not a biomarker to see if you're sick. We are offering biomarker to see if you're healthy. And if you have a reduced risk of getting sick in 10 years, 15 years, 20 years. So it's to optimize your life, your diet, you know, how you live, your lifestyle. So you will not be sick in the years to come. So this is a big difference what really happening in the health system today. The health system is rigged to see if you're sick now and then to treat you. But our offering is to avoid getting sick. I think this is a very important distinction.
Absolutely. Preventative health is the most powerful aspect of it. I've said numerous times, and I've been criticized for saying it, but that's okay. In the UK, we don't have a national health service. We have a national sickness service. Right. You only get involved when you're sick. Right. And we need to empower preventative steps, and we have to empower health with the same sophistication of methods, but before the disaster takes place, so that you can hit the brakes, you can make informed choices to change the outcome rather than deal with the situation as it falls upon you. Yes. So thank you, Thomas. We're just about on the hour, and I know we haven't picked up every single question, folks, because as always, a ton of questions came through, and it's really hard to do the individual ones, but we tried to discuss why it's hard to do individual ones. But I want to thank you, Thomas. It was absolutely fascinating. I love it when you take it through those steps, and it's been more and more fascinating hearing about your background and what's led to the position you're in now and how you do what you do so well. I'd like to thank everybody for taking part, taking time out. I know it's the middle of the kind of the vacation period, so we really do appreciate you taking time out in your hundreds during such a busy phase. And next month, on the 15th of September at the same time, I will be welcoming Ida Marie Pedersen, who is somebody who is a powerhouse of the product team. Let me tell you, Ida is an absolute powerhouse of the product team, and she will be coming along. She's been involved with Zinzino for a few years now, a good while, and has had a heavy hand in much of the product development. So that will be a fascinating insight to what we have currently available, and also what's coming up in the future. So please do join us on the 15th, same time, same place, September, as we welcome Ida. One last thank you to Thomas. Fantastic. Thank you very much. Everybody, stay well. Enjoy the rest of the month, August, as we start to gravitate back towards more normal working lives. And I will look forward to seeing you then. Stay well. See you soon.